Hello, this is Dr. Hanaa Assil, and this is paper 1C of October 2021 in the IGCSE Edexcel syllabus. So the first question here is the diagram shows the particles in four substances A, B, C, and D. Which substance contains single atoms of one element? First of all, one element should mean that all of the atoms are the same. Single atoms means they are one alone, not in twos. So which box has all of them similar atoms and each of them is just one alone? So that of course would be the one in box A. Then the next question says, which substance is a compound? Well, you should remember a compound is something that is made up of different atoms chemically bonded together. So, which one would be a compound? That is obviously the one in C. Then he says, which substance could have the formula H2? You should realize that H2 is hydrogen. This is a gas, and that means the atoms should be far away from each other. And this is H2, so they should be diatomic molecules. So each of them should be twos and all the atoms should be the same. So that is the one in box B. The diagram shows the particles in substance E. Give two reasons why substance E is a mixture. What do you mean by a mixture? A mixture means two different elements added together, not chemically bonded together. So that is a mixture. The next question says fluorine has the smallest atoms in group 7. The diagram shows the electronic configuration of a fluorine atom, and he's saying state why fluorine has the smallest atoms in group 7. Well, let's look at group 7. Group 7 are fluorine, chlorine, bromine, iodine. Of course, as I go down, the number of shells increases, the number of electrons increases, and the atom gets bigger. So fluorine is the smallest because it has the lowest number of shells. Which row gives the correct number of occupied electron shells and the correct number of outer shell electrons in an atom of iodine? So we said iodine, where is iodine? It's in group 7. So we say if something is in group 7, it should have how many electrons in the outer shell? So the number of outer shell electrons is 7, but it is period 5, so the number of occupied electron shells should be 5. So the number of shells is 5, the number of outer shell electrons is 7. Remember, the number of shells is the same as the period. The number of the outer shell electrons is the same as the number of the group. The table gives description of the reactions of some group 7 elements with iron wool. Complete the table by giving a description of the reaction of fluorine. So as you see from the bottom up, let's go from the bottom up. Iodine needs heating, reacts very slowly. Bromine needs heating, reacts slowly. Chlorine does not need heating, reacts quickly. What about fluorine? Is fluorine more reactive or less reactive? You should realize that fluorine at the top there is more reactive, so it does not need heating and it reacts very quickly. State the relationship between the reactivity of group 7 and the size of their atoms. You should remember, in group 7, the one on top is the one that is more reactive. That is because it is the smaller atom, so it is more able to attract electrons. Remember that group 7 are non-metals that attract electrons. So the smaller atom at the top is able to attract electrons to its positive nucleus more than the one at the bottom. So as the atom gets bigger as we go down, the reactivity decreases. This question is about rusting. Water is needed for iron to rust. So we said for iron to rust, we need water. Name one other substance that is needed for iron to rust. You have to remember that. For that piece of iron to rust, we need water and oxygen. Give the chemical name for rust. Remember, rust is this. What is the chemical name for rust? It is hydrated iron 3 oxide. You have to mention that it's iron 3. This is not iron 2. Remember that the valency of something goes under the other. So the 3 that is under the oxygen is the valency of the iron. So it is hydrated iron 3 oxide. Then he says the diagram shows two methods used to prevent iron from rusting. So method A, he's covering it with plastic. Method B, he's covering it with zinc. And he's saying, explain how method A prevents iron from rusting. Remember, if I'm going to cover it with plastic, the plastic is a protective coating that does not allow the iron to react with oxygen or water around it. Now, what about method B? When I cover the iron with zinc, what is the name of this method? Galvanizing or galvanization. Explain how method B prevents iron from rusting even when the zinc coating is damaged. Remember, we said galvanizing. What is galvanizing? We said galvanizing is covering the iron with a layer of zinc by dipping or spraying. That's what we mean by galvanization. Covering the iron with a layer of zinc by dipping or spraying. Now, how does this protect the iron? We said that the zinc is more reactive than iron, so it loses electrons and becomes oxidized instead of iron. Remember that rusting is an oxidation process. It is loss of electrons or it is gain of oxygen. So when we have zinc touching the iron or covering the iron, the zinc is more reactive, so it loses electrons and becomes oxidized instead of iron. The table shows the number of protons, neutrons, and electrons in 3 species. Give the mass number of F. Where is F? That's F. Now, what is the mass number? You should remember, mass number is what plus what? Mass number is protons plus neutrons. So 7 protons plus 7 neutrons, that is mass number of 14. Give the electronic configuration of G. Where is G? How many electrons is in G? G has 7 electrons. How are you going to distribute them? We're going to put 2 in the first shell, 5 in the next one. So you just write 2, 5. Explain why F and G are isotopes of the same element. Remember, what do we mean by isotopes? If I look at F and G, where is F and G? They have the same number of protons, same number of electrons, but they differ in the number of what? They have different number of neutrons. He's saying refer to subatomic particles. So don't say they have the same atomic number or this different mass number. We're not talking about that. He's saying refer to subatomic particles. So you have to mention protons, electrons, and neutrons. So isotopes are atoms of the same element. Why is that? They have the same number of protons, same number of electrons, but they are isotopes because they have different number of neutrons. Okay, and then he says, explain why H is a negative ion. Where is H? H has 7 protons and 10 electrons. And remember that protons are positive and electrons are negative. So it has more negatively charged electrons than positively charged protons. So if it has more electrons, then it will have a negative charge. A sample of carbon contains atoms of mass number 12 and 13. The table shows percentages of these atoms. Again, when he gives you the percentages of the different isotopes and he says calculate the relative atomic mass, how do we do that? It is the mass number times its percentage plus the mass number of the other one times its percentage over the total percentage, which is usually 100. So this comes out to be 12.01. Remember, if he says give your answer to 2 decimal places, you have to give it to him in 2 decimal places. So this is 12.01 or 12.01. 2 experiments are done to determine the percentage composition by volume of a mixture of 3 gases carbon dioxide, oxygen, and argon. So he has these three gases in a mixture. In experiment 1, a student bubbles the mixture of gases through lime water. Of course, when you bubble gases through lime water, the one that reacts with the lime water is the carbon dioxide. The diagram shows the apparatus that the student uses. The student pushes the mixture of gases out of syringe A. Can you see where syringe A is? It's the one on the left. But no gas bubbles appear in the lime water. Give one change the student needs to make to the apparatus for gas bubbles to appear in the lime water. Why isn't he seeing gas bubbles in the lime water? Well, that's because that delivery tube is not going into the lime water. That delivery tube should be going into the lime water so that the gas bubbles through it. So the delivery tube from syringe A should be longer to enter the lime water. Then he will see bubbles of gas going through the lime water. When the apparatus in experiment 1 is set up correctly, the mixture of gases is bubbled gently through the lime water so that all the carbon dioxide is removed. The volume of the mixture of gases in A at the start was 76 centimeter cube. The volume of the mixture of gases at the end is 66. So of course the difference was the carbon dioxide. Calculate the percentage of volume by volume of carbon dioxide in the mixture of gases in syringe A. So he's just talking about syringe A. So the volume of the carbon dioxide will be the difference and the percentage will be the difference over the total times 100. Give the change in the appearance of the lime water. What happens when you pass carbon dioxide through lime water? It turns from colorless to milky or cloudy. Explain why the gas syringes in experiment 1 cannot be used to find the percentage of carbon dioxide in a typical sample of air. How can I use this to find carbon dioxide, percentage of carbon dioxide in the air? It will not work. Why? Because the percentage of carbon dioxide in air is very, very small. It's only 0.04%. Remember, if we go back to that, what we calculated, it turned out to be he had 13.2% of carbon dioxide in the mixture. That is why we could see a difference in the syringe. But if I put normal air that has 0.04%, the change in volume in the syringe will be too small. I will not be able to detect the change in the syringe. So it will not be an accurate estimation. In experiment 2, a teacher pushes the remaining gases over hot copper powder. The copper powder turns black because the copper reacts with oxygen. Argon is extremely unreactive, so it does not react with copper. Name the black substance that forms on the copper. Of course, when copper metal or copper powder reacts with oxygen, what does it give? It gives copper oxide, and the copper oxide is black. So that's why we get a black substance. Remember, when we talk about copper oxide being black, we're talking about copper 2 oxide. Okay, so just why the teacher uses copper powder instead of the same mass of large pieces. Again, if he says, why do I use in any experiment powder instead of large pieces? This is because the powder has larger surface area, so the reaction would be faster. Explain why argon is extremely unreactive. Why is argon unreactive? You should remember argon is in group what? It's in group 0. It has a full outer shell of electrons, so it doesn't need to lose or gain electrons. It already has a full outer shell. So we say it is unreactive. This question is about organic compounds. So he has a series of compounds and he says, give the letter of the compound that is not a hydrocarbon. Again, remember, what do we mean by hydrocarbon? Hydrocarbon means an organic compound that has carbon and hydrogen only. So which of these is not a hydrocarbon? Of course, it's this one, Y, which has oxygen in it. So this is an alcohol. It's not a hydrocarbon. A hydrocarbon should have carbon and hydrogen only, not oxygen. Then he says, give the letter of the compound that is a saturated hydrocarbon with the empirical formula CH2. Again, I want to remind you. Remember, we said CH2 is the empirical formula for alkenes. It is CnH2n. But it is also the empirical formula for a cyclic alkane. So he wants something that is saturated. Remember, saturated means no double bond. So you cannot say U or X. At the same time, I want it with empirical formula CH2 or the general formula CnH2n. So that would be the cyclic alkane, which is V. That is something that is saturated, no double bond, and it has the number of hydrogens twice the number of carbons. Then he says, give the letter of the compound that reacts with bromine in presence of UV radiation. Remember, which of these would react in presence of ultraviolet radiation? Ultraviolet radiation is the condition needed for reaction of alkanes with halogens. So bromine, reaction with bromine in presence of UV light, it must be an alkane. Now, I want the alkane that will give me this product with one bromine attached to it. So which one would react to give one bromine? That is W. That is the alkane. If I remove one hydrogen and put one bromine, that is called a substitution reaction, and that happens between alkanes and halogens. Then he says, give the letter of a compound that forms an addition polymer with this repeat unit. Again, if I want to know what was the monomer, now the one that he's drawing here is the polymer. If I want to know what was the monomer, remove the bond on the right, remove the bond on the left, and put a double bond in the middle. You end up with something that has 4 carbons with double bond in the middle. So which compound is that? That is X. Give the displayed formula of an alkene that is an isomer of compound X. Compound X, if I tell you what is its name, it is bute-2-ene. Bute because it has 4 carbons, 2-ene because it has a double bond on carbon number 2. Now, if he says I want the isomer of that, please don't draw the same compound. You want its isomer. So its isomer would be, instead of having the double bond and carbon number 2, it will be on carbon number 1. So the isomer of bute-2-ene is bute-1-ene with a double bond after the first carbon. Again, remember, the first carbon could either be the one at the end on the left or the one at the end on the right. The one at the end in either case would be 1-butene, because we said we count the numbers from the side that gives you the lower number. Okay, the other question says compounds U and X, can you see which one is U and X? These are the ones that have double bond, are members of the same homologous series. Members of the same homologous series have the same functional group. Give 2 other characteristics of compounds in the same homologous series. We said organic compounds are divided into groups. We don't call them groups, we call them homologous series. Now, members of the same homologous series will have the same functional group, so he already mentions that. Please don't mention it again. He already mentioned same functional group, and he wants 2 other characteristics. You should write same general formula, same chemical properties. So these 2 are alkenes. They have the same functional group, the same general formula. Remember that general formula of alkenes is CnH2n. They have similar chemical properties because they will do the same types of reactions. And we said alkenes do addition reactions. Okay, compound Z contains these percentages of carbon, hydrogen, and oxygen. And he says, show by calculation that the empirical formula of Z is CH3O. So that means he wants me to calculate or to find out the empirical formula. How do we find out the empirical formula? We write the percentages that he gives us. Carbon is this percentage, H is this percentage, O is this percentage. Then we go through 2 main steps. The first step is what? Divide by the mass number. So we divide each one by its mass number. The one for carbon by 12, the one for hydrogen by 1, the one for oxygen by 16. I end up with numbers. Now I look at these numbers, and the next step would be divide by the smallest. Which one is the smallest? I divide all through by the smallest. I get my answer at this stage should be a whole number, 1 to 3 to 1. If it is not a whole number, you have to multiply through by a number that will turn it into a whole number. But this one is a whole number, so just let's continue. It is CH3O, so that is correct. And then he goes on and says the relative MR, the relative formula mass of the compound is actually 62. Deduce the molecular formula. Again, remember, empirical formula means the formula that gives the smallest ratio or the lowest ratio between the atoms. The molecular formula will show the actual ratio. So he's telling me the MR of this compound should be 62. So the first thing I do is I get the MR of what I have, MR of CH3O. The MR of CH3O is 31. Now he's telling me it shouldn't be 31, it should be 62. 62 is twice 31, so my actual molecular formula is twice of what I got there. So it is C2H6O2. Then we're talking about nitrogen and oxygen, and he said nitrogen and oxygen do not react at room temperature. At the high temperatures in a car engine, nitrogen and oxygen react to form nitrogen monoxide. Give a chemical equation. Again, I'm reminding you, give a chemical equation means a symbol equation, not word, and it has to be balanced. Whether he mentions or not, a chemical equation has to be balanced. So what is he saying? He's saying nitrogen. Remember that nitrogen is diatomic, so I write it as N2. Oxygen is diatomic, O2, and he's saying this will give me NO, and then I need to balance. Give a reason why this reaction only occurs at high temperatures. We said this will react at very high temperatures, whether it's in the car engine or in a furnace or in the air if there is lightning. So why does this need a high temperature? Because nitrogen is unreactive. Or you could say because the reaction has a high energy of activation. If he tells you that a reaction is not easy to perform or it doesn't work easily, that must mean that it has a high energy of activation. Do you remember what's energy of activation? It's the minimum amount of energy needed to start a reaction. Then we say nitrogen monoxide gas can be removed from car exhaust fumes when it reacts with carbon monoxide gas. This is what happens in what we call the catalytic converter that they put on car exhaust. So they cause the nitrogen monoxide gas and carbon monoxide gas, which are both harmful. They react together to form safer gases. The rate of the reaction is increased by passing the gases over a catalyst. Now explain how a catalyst increases the rate of reaction. What does a catalyst do? You should remember that the catalyst provides an alternative pathway that has a lower energy of activation. Remember that in any of these energy profiles, the energy of activation is the distance from the reactants to the top. That's what we call activation energy, from reactants to the top. So if we use a catalyst, this energy of activation is lower. This top goes down a little bit, so the reaction is easier to perform. Explain how increasing the pressure of gases increases the rate of a reaction. When I increase the pressure on a gas, I'm basically pressing the particles nearer to each other, so the particles are closer to each other, so more collisions can occur per minute or per second, per unit time. Ammonia is a simple molecule with the formula NH3. Complete the diagram to show the outer shell electrons of ammonia. Again, remember that ammonia is made up of 1 nitrogen and 3 hydrogen. This is because if you look at the periodic table, nitrogen is in group 5. It has 5 electrons in its outermost shell. So it needs how many? It needs 3 electrons to have a full outer shell, which is 8. Now, each hydrogen can donate 1 because each hydrogen has 1 electron and it needs only 1. So each hydrogen shares one electron with the nitrogen, and the nitrogen still has the rest of its 5. So you need to put the other 2 electrons away from the sharing between the nitrogen and the hydrogen. The bonds in ammonia are covalent. Describe the forces of attraction in a covalent bond. If he says what is meant by a covalent bond, or what are the forces of attraction in a covalent bond, well, you have to remember it is the strong attraction forces between the bonding pair of electrons, so the electrons in the middle that we're trying to share, and the positive nuclei of each of the atoms. So I have a positive nucleus for each of these 2 atoms attracting the 2 electrons that we're trying to share. So it is strong attraction forces between the bonding pair of electrons and the positive nuclei of the atoms. Explain why ammonia has a low boiling point. Again, if he says why anything has low boiling point or low melting point, it is because it has what? It has weak attraction forces between molecules that need a small amount of energy to be broken. Anything that has a low melting point or a low boiling point would mean that it is a simple molecular structure. And a simple molecular structure has weak attraction forces between molecules that need a small amount of energy to be broken. Barium chloride can be made by reacting barium carbonate with dilute hydrochloric acid, and the chemical equation for the reaction is this. Describe a method to produce dry crystals of hydrated barium chloride, starting with barium carbonate powder and dilute hydrochloric acid. Again, this is trying to describe how to make a salt. And we said there are 3 methods for preparation of salt: titration, neutralization, and precipitation. Now, which one is this? I am starting with something that's insoluble. I'm starting with barium carbonate, that's a solid, and I'm trying to make something that is soluble. So I'm basically trying to explain the neutralization method. What do we do in the neutralization method? We add the barium carbonate to HCl in a beaker using a spatula. Stir until excess solid remains in the beaker. Remember, the barium carbonate, at the beginning, it will react and dissolve, and then react and dissolve. And remember that it will give off fizzing because it's giving off carbon dioxide gas. How do I know if the reaction has finished? When the solid no longer dissolves, some excess solid remains in the beaker, or when there is no more bubbles of gas. When I am finished with that, I have excess solid in the beaker, so I filter through filter paper and funnel. I take the filtrate, so the filtrate will be my barium chloride solution. Heat the filtrate until point of crystallization. Cool to form crystals. Filter the crystals, so you get the crystals now in the filter paper. Wash with a few drops of distilled water and dry the crystals between filter papers. This is how we prepare a soluble salt, starting with an insoluble reactant. A colorless solution contains sodium carbonate and sodium sulfate. Describe a test using barium chloride to show that the colorless solution contains sulfate ions. So basically, he's telling you describe the test for sulfate. What is test for sulfate? You add dilute acid. Remember, it has to be acidified. You add dilute. So if I'm using barium chloride, it is dilute HCl. Remember that this test can also be made by barium nitrate. In that case, I will use dilute nitric acid. So with barium chloride, I need dilute hydrochloric acid with the barium chloride. If I have a sulfate, I should get a white precipitate. A student investigates the reaction between solid hydrated sodium carbonate and dilute hydrochloric acid. She uses this method to investigate the temperature change during the reaction. So he's saying pour 25 centimeter cube dilute hydrochloric acid into a polystyrene cup, record the temperature, add 0.5 grams of sodium carbonate, stir, record the lowest temperature, Add further 0.5 gram portions of sodium carbonate, stir the mixture, record the lowest temperature. So he has a table with the temperatures and he's saying plot the student's results. So I'm going to plot these results using small x's, and then we're going to draw a curve of best fit, ignoring the anomalous result. Remember, the anomalous result is the one that is away from the curve. So if you find that you have to bend the curve to take in a result, then that's anomalous, because your curve should be a smooth curve of best fit. Explain why it is better to use a polystyrene cup instead of a glass beaker. Remember, if we're doing any experiment that involves measuring temperature, then it is much better to do it in a polystyrene cup, because the polystyrene cup is an insulator. So there is less transfer of heat. In this case, actually, the temperature went down. So this is an endothermic reaction. So actually, I'm trying to prevent heat entering into the reaction. If it was something in which the temperature was going up, I would say to prevent loss of heat to the surroundings, but here it is, well, to prevent transfer of heat from the surroundings. A polystyrene cup is an insulator, so we always do reactions involving temperatures in a polystyrene cup. So if he says he did it in a beaker and he's asking me for an improvement, I would tell him, instead of using a beaker, you should use polystyrene cup. So just the reason for the anomalous result. Where was the anomalous result? It was a little bit higher than what it should be. So what do you think went wrong? Well, probably the sodium carbonate he added was less than what it should be, or the recorded temperature was done before it stopped decreasing. So it should have gone lower than what he measured. State how the results show that all the dilute hydrochloric acid has reacted. Well, the last two results are the same. Remember that if the reaction has finished, then the temperature remains constant or the results remain the same. Use the results of the experiment to explain the type of reaction that occurs when sodium carbonate is added to dilute hydrochloric acid. Remember the results, the temperature went down. That means the experiment is endothermic, takes in heat, the temperature decreased. The student does another experiment using the same reaction where he puts sodium carbonate with dilute hydrochloric acid. The mass on the balance decreases because carbon dioxide gas escapes. Now give a reason for the cotton wool plug. Remember, when we do this kind of experiment, we're putting it on a balance. So we're measuring the change in mass or the loss in mass because the carbon dioxide escapes. So I need the carbon dioxide to go out, but if you have seen any solution that is giving out a gas, the solution is usually bubbling over or trying to splash out. So I don't want the solution to splash out, and that's why we put the cotton wool at the mouth of the flask to prevent loss of solution by splashing and at the same time allowing the carbon dioxide gas to escape. The student adds 2.12 grams of sodium carbonate to an excess of dilute hydrochloric acid. Calculate the maximum mass of carbon dioxide formed. Again, this is chemical calculation. He gives me information about sodium carbonate. So I need to use this information to get the number of moles of sodium carbonate. Of course, if he gives me mass, then that means I need to use mass over molecular mass. Molecular mass of sodium carbonate, you can calculate it. It comes out to be 106. So the number of moles will be mass over molecular mass. That comes out to be 0.02 mole. Then the next step would be look at the equation, compare the number of moles that we got to the number of moles he's asking about. The equation is he's asking for carbon dioxide, and the equation says 1 mole of sodium carbonate. Remember, there is no number in the equation in front of sodium carbonate on the left, so that means it's 1. It gives 1 of CO2. Also, there is no number in front of the CO2, so that is 1. So 1 of sodium carbonate gives 1 of carbon dioxide. That means the number of moles of carbon dioxide is the same as the number of moles of sodium carbonate. Then we try to get what he's asking for. What is he asking for? He's asking for mass of carbon dioxide. Mass is number of moles times mR, and that comes out to be 0.88 grams. Then he says, suggest why the mass of carbon dioxide produced is less than calculated. Remember, when we are trying to get mass of carbon dioxide, it is usually less than what it should be, and this is because carbon dioxide is soluble in water, so some of the carbon dioxide gas dissolves in the solution. Or if you want a second reason why the mass is less, then we say that the compound that we started with, which is sodium carbonate in this case, was not pure, and that's why it did not give the mass of carbon dioxide that it was supposed to give. This question is talking about this apparatus, and you should realize the name of this method. This is fractional distillation. Name the change of state taking place at A. What is happening at A? We're heating the liquid and until it reaches boiling point. So at A, what is happening is, you can either say evaporation or you could say boiling. Then he says, name the change of state taking place at B. Remember that B is a condenser, and what is happening is condensation. We're cooling the vapor until it changes from gas to liquid. So that is condensation. The mixture contains 15.5 centimeter cubed of ethanol, and he's saying 1 centimeter cubed of ethanol has a mass of 0.79 grams. 1 mole of ethanol contains this number of molecules. Calculate the number of moles of ethanol in 15.5 centimeter cubed. So the first thing is the mass. The mass would be, he says 1 centimeter cubed has a mass of 0.79, so the 15.5 centimeter cubed would have a mass of 12.245 grams. Then the number of moles is this mass over the molecular mass of ethanol, and that would be 0.266 mole. Calculate the number of molecules. You should know that 1 mole contains 6 times 10 to the 23 molecules. This is called Avogadro's number, even if he doesn't give it to me. To get the number of molecules, then we should multiply the number of moles by Avogadro's number. So the number of molecules would be 1.6 times 10 to the 23 molecules. After 5 minutes, the teacher collects a sample of colorless liquid in a new beaker. Describe a chemical test to show that this liquid contains water. What was the chemical test for water? You should know. Add anhydrous copper sulfate. It turns from white to blue. Describe a physical test to show if the colorless liquid is pure water. What was the physical test for water? Heat to boiling. It should boil at 100 degrees Celsius. The teacher uses this apparatus to heat 100 grams of water. He records the temperature of the water before and after heating and calculate the heat energy change Q. How do we get Q? We said Q is mc delta T. M is the mass of the water, which is 100, times C, which is 4.2, that's a constant number, times delta T, which is the change in temperature. That comes out to be 20,790 joules. Remember, the answer to this equation is in joules. Then he says the student burns 0.02 mole of ethanol. Use this information to calculate delta H. How do we get delta H? You should realize delta H is Q over N. The Q, if you put it in kilojoules, so you divide by 1,000. So this 20.790 is the answer that we got previously, divided by 1,000. Then you divide by number of moles. And remember that delta H must have a sign. How do I know what is the sign? If the temperature rises, in the question he said that the temperature rises, that means that it is exothermic, and that means the delta H has a negative sign. Don't forget the sign. This question is about reactivity of metals, and he gives me, remember that a metal, if the metal reacts with the solution of another metal or the salts of another metal, that means that original metal is more reactive. So if I say manganese with chromium sulfate reacted, that tells me that manganese is more reactive than chromium. Then he did tin with cadmium sulfate, it did not react. If it did not react, that means it is the cadmium that is more reactive. Now, chromium with cadmium reacted, and that means that chromium is more reactive than cadmium. So what type of reaction is this? When we have one metal pushing the other metal out and displacing it, this is called a displacement reaction. Use the information table 1 to complete the order of reactivity. So manganese is more reactive. Now which one is next? We said chromium is more reactive than cadmium, and cadmium is more reactive than tin. Table 2 shows the colors of 4 metals and the colors of their sulfate solutions. So when a metal is added to a metal sulfate, there may be a color change on the surface of the metal and in the solution. Use the information in table 2 and your knowledge of the reactivity series to explain any color changes in these two experiments. So when he added copper to magnesium sulfate, now copper to magnesium sulfate, what would happen? Remember that magnesium is more reactive than copper, so you will not have any color change. Copper cannot displace magnesium. Copper is less reactive than magnesium and cannot displace it. Then he's adding zinc to iron sulfate. So let us see. First of all, will it react or not? Yes, we should know that zinc is more reactive than iron, so it can displace it. Then we should look at the table. The iron sulfate solution is what? The iron sulfate solution is green. Now, when I add zinc, it will displace the iron, so it will change the zinc from light gray to dark gray, because the iron will make a coating on the zinc, and the solution will change from green to colorless because it changes from iron sulfate is green, iron 2 sulfate is green, and the solution, when it becomes zinc sulfate, this becomes colorless. This is because zinc is more reactive than iron and it will displace the iron out of the solution. A different experiment can be used to place metals in order of reactivity. So this is the method. Step 1, add 1 gram of a metal to 25 centimeter cubed of dilute acid. Measure the volume of gas produced in 1 minute. Give 2 variables that should be controlled. What are we changing? We're changing the types of metals, but we should keep, for example, the concentration of the acid the same, the temperature the same, the surface area of the metal the same, so any 2 of these would be correct. A small piece of calcium is added to some dilute sulfuric acid. One of the products of the reaction is insoluble in water. That means when he says insoluble in water, that means it will form a precipitate. So just while the reaction stops after a short time, even though the beaker still has calcium and dilute sulfuric acid. So we have calcium and sulfuric acid reacting, but he's saying that after some time, the reaction stops. Remember that when the reaction happens, it forms calcium sulfate, and he's telling me that the calcium sulfate is insoluble, so it will form a precipitate. This would cover the surface of the calcium metal and prevent it from reacting with the acid. Then the last question says 1 gram of aluminium is added to 0.06 mole of dilute sulfuric acid. Show by calculation that the sulfuric acid is in excess. When he says that, I should get the number of moles of each of the reactants, compare them, and see which one is too much. So he says I have 1 gram of aluminium. Get the number of moles of aluminium. In this case, it will be mass over molecular mass. 1 gram over the mass number of aluminium, this is 0.037 mole. And then I look at the equation. What amount of acid do I need to react with that? The equation says if the number of moles of aluminium is 2, the number of moles of sulfuric acid should be 3. So if it is 0.037, then the sulfuric acid should be what? 0.037 times 3 over 2. So what I actually need is 0.0555 mole of acid. Now, how much did he add? He added 0.06. That is too much. So that means that it is the acid that is in excess. Okay. Thank you very much for bearing with us. I hope that this was useful to you, and thanks for listening.